Okay, this is the next installment I promised you for the brushless DC dynamometer. I have got the load cells from DigiKey. You can see them in there. I've got 4 of them. Very basic things. And if you look here, very basic, I've mounted one on here. Let's see if I can manually focus that a bit better. Sorry about that. No, we are focused at the minimum. So as you can see here, there's actually clearance. Here's about 1mm clearance there, but this part here pushes on there, so when the motor spins the shaft this way, we get a counter torque that way, and that puts a strain in here which we can measure. So I know the radius at which that point of contact occurs, and it's perpendicular through here. That's all been measured up, so that point of contact there where you can see it on the little bearing there, I know the exact radius from the center of the motor, so by knowing that force I can directly equate that to torque. Having said that though, probably the easiest thing for me is I'm going to fit something onto this motor with a known length of probably, I don't know, 300mm or something, maybe 250, so it's easier to calculate, and then put a known force on that, and then just do maybe 3 or 4 calibration points, which allows me to convert that measured signal directly to a torque measurement. So that then goes into one of these little Spark Fun PCBs that that's got a HX711 Delta Sigma ADC specifically designed for load cell applications, and it's sort of a serial output, data clock output. I'm hoping that I can connect 2 of those to a couple of pins and an Arduino. I'm just looking at the code on that at the moment. I don't think it uses any fancy ports. I think it's just bit bashing, which is easy. We don't need high data rates on this. So I'm going to have 2 of these running. One for the torque, like we measured, and then I've got this bearing here because I've got a little bracket. And on the main assembly that I've shown you pictures of previously, I'm going to put another one of those load cells across here, and I'm going to calibrate that for force. Now, this does have some weight, and to keep things simple, I'm probably going to do the initial testing vertically in water, which means I can calibrate out the weight of this part of the assembly quite easily, and just add that then to any positive thrust that we get. I don't think I'm going to squeeze the strain gauge against it so I get negative values. I'm just going to work on stuff above this, because this is probably about 1 kilo all up, and I'm expecting quite a bit more thrust than that off this. So that's that assembly. This just here, 2 M5 bolts. It's actually threaded. Focus. It's actually threaded in here, so I just need to screw them up from underneath. They went straight through and went tight. That all went together beautifully. Nothing on this end. That's free. Main intention there is that I get it there in the middle between the 2 screws, which is the recommended point that they recommend. The shape, the trapezoidal shape here, means that you've got a fair bit of leeway in terms of the point of contact there where we're putting that pressure on. It doesn't tend to do that. It tends to do that because of the trapezoidal shape. Yeah, so that's the next bit. So I'm going to be fitting this up tomorrow onto the base with the remaining load cell, and I'm going to start coding this up so that I can start actually testing it. So I'm looking forward to seeing how this actually works out. So there's been a lot of interest in this project. I hope if you've got any questions, please let me know about them. Leave some comments. I'd like to keep you updated. I'm not sure what you like about this. Like I said, there's been a lot of interest in this video, so if there's more that you'd like to see on this and what I do, because the next part's going to be, once we've tested and baselined this motor, I'm going to test another motor like this with a higher kV, and then I'm going to go straight into mounting the gearbox on here and testing the same setup at a much higher kV, probably doing around about 5 times the RPM in the motor, while still keeping the prop at the same RPM. I should see a significant drop in the amount of power I actually need. I think there's going to be an efficiency improvement that I get there. I could be wrong, but I reckon this motor is running into torque limit and saturating when it's direct drive. So that's why I'm doing this experiment. It's a bit of a learning exercise. So thanks for being on the journey with me. I'm really glad you enjoyed this one, and I will try to create more content like this. Like I said, like and subscribe and leave some comments, and we'll take it from there. So thanks for watching, everybody.